All right, I have sent you all a couple of files. They're ASCII files, that's ASCII. They're just text files that are programming code for using the R software, statistical software. It's very popular, very well used and well known. If you have not heard of it, we are introducing you to it right now. I go to the R project for statistical computing. I would go to the download page and I'm going to look for my particular region of interest, if it's Columbia, if it's the United States. I personally am nearby Pittsburgh, so I'm going to grab Pittsburgh out of here, right there, download it for the Mac OS or download it for Windows. I click this and I've given my package to download and I can then install it. So you're going to install R 3.0.2 if you have Snow Leopard. If you have other Windows operating systems, you just pick the most logical install. Any of them will really work. The other one that I told you to install was RStudio. Now RStudio is a development environment that makes R super cool, super easy. And you basically just go right here to download now. It already knows what type of operating system recommended is going to be Mac OS 10 for me. So I would download that guy, install it, and I'm off. Okay, so that in and of itself probably took me 5 minutes the very first time I did this, which was a few days ago on this rather new computer that I have. So close that up, and I can actually close this for a second. I want to show you what it looks like to load R. So there's RStudio and R. I load up R, and I've got this environment here that is a console environment, and I'm going to recommend that you can look at this, but realistically what I actually want is to use RStudio to interface with R, because R is really kind of the basic engine for what we want to do. So I'm going to launch RStudio instead, and you're going to see that I have 4 different windows. One is my source code region. It's also my viewing region for my data files that look a lot like Excel files. My console region, this was very similar to what you saw when you were looking at the original R console. I've got my workspace that stores my variables. I've got a list of historical commands that I've used. And I've also got areas where my files are listed, my plots are displayed, where I can export them, and if I need any new packages in R, I can install them. Okay, so let's just go right away. We're going to open up a file. In my case, I've got most of my files stored in a folder in Dropbox called Solar Calculations, and so I'm going to bring up that R coding for Penn State in July, right? So I open that up, and right away I've got code right listed up here, and you're going to see that I have this button Run. If I hit Run, it actually executes the line that I was sitting on, line 1, hit Run again, and I execute line 2. Now, in our case in R, the pound sign is just a comment, so it's not actually executing anything. I want you to just read through what I've written in here, begin coding in R, and I get into my first line that I'm going to run, which is to download that surfrad file. This is going to be the surfrad file for 07/07/212. So 2007, the month of July, day number 212, and we know that from our prior work in activity 3.2. I am going to do some things where I'll strip some data out to create a subset of clean data, and I'm going to assign a header to that data. Now each time I'm just clicking on the right line that I want to run the current line, and I hit run, and I have it. And then I'm assigning that list of headings. I typed out all those headings, and now I'm going to assign it to surfrad. I can do that to any file. And finally, I'm going to view that data. And there it is. So I've got my data of year, day, month. All this stuff is all listed out. And the beautiful thing is I can just follow through and plot my data. So I plotted my data right over here I've got the plot. Easy as can be. You're going to see that I'm going to take the file surf underscore PSU underscore 0707212. Then there's going to be a dollar sign. The dollar sign is saying inside of this file, I want to select the column DW Solar. And I want it to be a line plot, so that's why that L is in apostrophe there. I can do the same thing for the diffuse plot, and I get a new plot of the diffuse energy. Now, of course, this is not scaled appropriately, so we want to fix them. And I'm going to still just run on through down here, take another look at my plot because I've added row names, click back to my coding. All I'm doing is just clicking run to step line by line through and see what the code is actually doing. I want to read what's happening, but here I've gotten to plotting the diffuse on a common scale, adding a title, and then this lines is going to add another plot. That's my global horizontal irradiance. And I have confirmed that Excel is way slower to do this same thing. I can go over to this image. I can zoom this image and look at what it looks like. That's a pretty sweet plot. And I can go to export, save the plot as a PDF in the size that I want, name it something, and I'm off and running. So let's just call this psu.pdf. Call it psu surfrad July 31, something along those lines. And I've saved it. There's my file for submission later. Okay, and if I go to open again, and I go down to my recent files where solar calcs were, and I grab the R file for KT, that's where I can run through my lesson for, there we go, I want to get KT, and I'm going to do the same thing where I'm going to run some files that will ultimately allow me to make my trigonometric arguments in degrees, and I'm going to show how I could sum up data, cumulatively sum up data from cells from rows 241 to 260 and rows 361 to 380. Those are the two time zones that I want. You notice here that I've got the name of the data frame, the name of the actual data file. I've got DW Solar, downwelling solar, that's the name of the column. And then in brackets, I've got the specific rows that I'm interested in. And that's as simple as it gets for summing these things up. So we're going to read through these things. Ultimately, I've got all the basic math of calculating things like the equation of time, the declination, which we need the equation of time, the B value for the equation of time. I've entered in latitude, and then I've got hour angles that I'm calculating, run through, and I can calculate the extraterrestrial value in the morning, the extraterrestrial hourly value in the afternoon. That was 7 to 8 in the morning, 1 to 2 in the afternoon. And if I go to the far end of this calculation, you'll see that I divided each by 1 million, so that my units will come out in megajoules per meter squared. Finally, I've got some integration strategies. You don't need to know how I did the integration necessarily, although you can certainly analyze it. You'll just see that I will get integrated values of morning and afternoon that I could probably type right down here, morn, in my console, hit enter, and oh, there it is. 1.22 megajoules per square meter in the morning. Type aft, and I get my printout of 3.14 megajoules per square meter of irradiation from the 1 o'clock to 2 o'clock hour on July 31st. And then I can hit tab, and I will get my selection of what I've already calculated. So it already knows what to look for. And it will tell me that my afternoon outer space was 3.33 or 3.34 megajoules. My afternoon measured was 3.14. From that, in the afternoon, I can run this one line. I can jump ahead and run lines, right? K, oops, I want to get out of that. Let's see here. There we go. I want to look at what my KTPM is, and it is a KT value of 0.94, and I can use that in my future functions to calculate irradiation on a tilted surface. So that's your jump start. The interesting thing that I can do here is if I really wanted to do something easy to find out January 3rd, all I would need to do is go up to this R coding file, hit search. You know the day number is 212. You can replace it with day number 3, that's January 3rd. And all I would have to do is selectively just go through replacing all these days, right? And as long as I paid attention so that the day N, you'll see it, we'll pop down to it. I'm just selectively replacing, okay, in that one, and I can save this guy as a separate file. Go down to save as, and I could save him as PSU coding Jan. And there's my file done. And you see that my plot changed and it's centered over noon like I want it to be. And then I can go to that same associated code for KT and do the same thing. Go to search 212. Going to replace 212 with 03. Really simple replacements. I'm just going to keep an eye out for that day N because I want day N to be actually the number 3 rather than 003. So bam, that was the only thing I had to look out for. Otherwise, I'm just going to go to next, replace, replace. And now, no more occurrences. My code has now been rewritten for January 3rd. I can run it and find out my KT values in minutes. Save it as KT underscore Jan, and I'm off. Okay? Good luck to you in your work. I hope this is helpful. I certainly believe that this will help us in the end to actually dig into the data faster and do some good learning rather than fighting with Excel. Good luck.